Sheila Dean, who has been with us before, is coming back to talk about macronutrients and micronutrients. And Sheila is a clinician at the Palm Harbor Center in Palm Harbor, Florida. She's a dietitian, PhD in nutrition. She's also very much an educator and somebody who is educating both through the professional textbooks to which she contributes, through popular media, and also as a faculty member both here and at Saybrook University. So she's going to take us on this tour, which for some of you will be a kind of a brilliant review. For others, it will be somewhat introductory, and that's fine. You just take in. Some people have said, "Well, I haven't been able to take in everything." That's fine. Take in as much as you can, and enjoy the next couple hours with Sheila. Please come on up.
Thank you. Good morning. How is everyone? Are you happy to be here? Well, I'm very happy to be here. It is really my pleasure to be here. I so appreciate the opportunity to present for such fine organizations like the Center for Mind-Body Medicine that I think is doing a fantastic job educating clinicians around the nation with respect to, not just food as medicine, but really food is powerful medicine. So what I hope to do for you in the next hour and a half, and of course we're going to be taking a break in between macro and micronutrients, is to just sort of highlight some of the key aspects. Obviously, it would be impossible to do a comprehensive review of macronutrients, which is typically done in a full semester, right? So we have about an hour and a half to cover both macro and micronutrients, and I will do my best to cover some of the highlights. Are you ready? Okay. Okay. Let me just start by identifying some of our objectives for today. We're going to identify a few key roles of macro and micronutrients, not just for adequate nutrition, but really for optimal nutrition. We'll apply some of these recommendations into clinical practice. We'll talk a little bit about how dysfunction precedes pathology and talk about how disease exists on a continuum. We'll discuss a few drug-induced nutrient depletions and interactions, and then talk a little bit about potential nutrigenomic implications and applications. So quite a bit on the agenda for today. So let me just start with the basics. Most of us are probably familiar with this list here, the breakdown of our nutrients, which are essentially your carbohydrates, your lipids, your protein, and those would be our macronutrients, and then vitamins and minerals being our micronutrients. And of course, water is considered obviously a major classification of our nutrients as well. So there's a lot of information on this particular slide, but this is sort of an overview slide. Oh, let me also mention right now that some of these slides are a little bit modified from what you have in your syllabus, but you will get all of my updated slides again. So if there are any little extras or anything that I've pulled or modified, I promise that you'll all get that. So no worries there. So back to the slide. So the way I've categorized and broken carbohydrates down is in terms of simple sugars versus starches versus non-starch polysaccharides or fiber. In textbooks, sometimes you'll see this discussed as simple sugars versus complex carbs. And I don't really like using the word complex carbs because I feel like that term sort of implies that simple sugars bad, complex carbs good. And I think that we have to clarify that. We know that our simple sugars include your natural sugars, your fructose and fruit sugar, your lactose and milk sugar, and of course refined sugar, which is sucrose and table sugar. But starches can also be broken down. So yes, we do have our complex carbs or our whole carbs, but then we also have our simple starches, or our refined starches, which we'll talk a little bit more about. Now your non-starch polysaccharides or fiber obviously can't be broken down in the body, so your body doesn't convert these substances into, or these carbohydrates into sugar. And then that can be categorized further down as well into insoluble fibers, such as your celluloses, your hemicelluloses, lignin, etc., that's not fermented by the bacteria in the colon. Your soluble fibers, so those would include your gums, your mucilages, your pectins, which are found typically in our fruits or veggies, rice bran, psyllium seed. And then, of course, there's another classification which we'll talk about a little bit, which is called resistant starches, which is sort of like a starch fiber. And we'll talk about that in a little bit more detail in just a moment. I like this picture because what it illustrates is the insoluble fiber, the celluloses in the skin, and then you can see a picture of the pectins in the center. So just to kind of give you a visual of where this fiber is actually located, for example, in an apple. And this particular, the picture underneath it is showing you that the endosperm is the starchy component of the grain, and then the nutrient-dense bran and the germ are usually removed in the processing of the grain. Okay, so if we had to break it down, the endosperm is sort of the starchy, less nutrient-dense component of a refined carb. So a couple more other key features. So simple simple starches, they're so simple that as soon as they enter the stomach, they can be denatured by the presence of the hydrochloric acid. When they get into your small intestines, you've got this rapid absorption and an immediate blood sugar response. Simple starches have a similar effect on your blood glucose as simple sugars because some of the amylopectins have so many branched chains that there are a large number of sites where your digestive amylases can work on these simple starches. So really, it's about surface area. Let me just show you this picture. What you see here is the amylopectin and the branched chains and all those different places where those amylase enzymes can really work at it. Now, your resistant starches are really quite different. They're much more difficult to digest. They're going to contribute just a small amount of glucose in the bloodstream over an extended period of time. Your dietary sources are going to be your beans, your lentils, your whole grains, such as your oats, barley, and rice, your yams, sweet potatoes, squash. Resistant starches really want to be the majority of the starches in your diet, or the majority of the carbs in your diet. Now, in general, really what makes a carb have a higher glycemic load and a greater contributor to blood glucose levels really has to do with one key thing, and that's its digestibility. It's really better to eat carbohydrates that's difficult to extract all of the sugar out of. So resistant starches are long chains of glucose with very little branching. This is just a quick picture that shows you the blue line is the line that represents the blood sugar response of Hispanic women after the consumption of resistant starch as compared to the yellow line, which is the controlled granola bar. You can see right away that there's a much higher blood sugar response in those who had the controlled granola bar as opposed to the consumption of the resistant starch, which really only has, which again, the resistant starches are these long chains of glucose with little area for digestion. So you're going to have much slower digestion and, of course, increased satiety. Let me go ahead and move on to another term that you may have heard of, fructooligosaccharides, or FOS, also known as prebiotics, so not to be confused with probiotics. So these prebiotics are sometimes referred to as the food or the fertilizer for prebiotics, or the flora or intestinal flora. They don't tend to raise your blood sugar levels. They do require the action of flora and gram-positive bacteria to digest it, and your sources are essentially going to be your fruits, your vegetables, your grains, and legumes. Moving on to soluble or functional fibers, I think we probably already know that it requires a lot of water for absorption. Soluble fibers help to nourish and support that gut flora, those prebiotics that I was talking about. They help to lubricate the distal GI wall and help with the ease of elimination. Your sources are going to be your apples, pears, plums, lentils, oats, onions, chicory, squash. Now, the dietary reference intakes are currently about 14 grams of dietary fiber per 1,000 calorie consumption, or about 25 grams for adult women and 38 for adult men. However, if you really take a look at some of the epidemiologic studies showing protection against certain cancers and cardiovascular disease, you'll see that those numbers go a little higher up, maybe even closer to 50 or 60 grams per day. Now, if you've done an assessment of your patient's fiber intake and you've assessed that their intake is pretty low, you're not going to want to start them right away on 50 or 60 grams of fiber because that might cause some GI distress. So you really want to start low and go slow. Okay, so it's okay to ease them into this. It doesn't have to be right away. In fact, if it is, they might be calling your office the next day complaining. Just an interesting study that I just pulled out just this past month out of the Journal of the Academy of Nutrition and Dietetics, formerly known as the Journal of the ADA, a study that showed that daily fiber intake generally still has not progressed towards our national goals during this entire past decade. So obviously we still have quite a bit of work to do. Now, soluble fibers as they relate to something called short-chain fatty acids. These soluble fibers are really, really critical for the production of short-chain fatty acids. Short-chain fatty acids are, just think good. These are fatty acids that are produced in the intestines. They help to heal the digestive lining. They're produced by the action of resistant starch and microflora. So they help to prevent or reduce your risk for various inflammatory bowel diseases like Crohn's and colitis. And now short-chain fatty acids can be measured in various stool studies. Here's an example of a lab that actually does measure beneficial short-chain fatty acids and the different kinds, particularly N-butyrate, which is probably the most important, most significant short-chain fatty acid. And you can see it as one example. This particular lab shows that this individual had low short-chain fatty acids and low N-butyrate. And so someone like this is going to be a candidate for probiotics, making sure they're getting a lot of fruit and vegetables in their diet, and of course fiber, especially those soluble fibers, because that soluble fiber is what's going to act on the flora, the gut microflora, to help produce these short-chain fatty acids. It's a really important pearl over here. Moving on, so beta-glucans are another form of soluble fiber that I just wanted to mention. Your beta-glucans are polysaccharides of something called D-glucose monomers that are linked by beta-glycosidic bonds, but more importantly, you'll find them in foods like amaranth and buckwheat, barley, and quinoa. Beta-glucans are typically thought of as excellent sources in oats, but you'll actually get more of it in other foods like I just mentioned, the amaranth and the buckwheat. If you start to read the research, what you see is that beta-glucan's ability to upregulate the immune system is really where the research on beta-glucans really shine. That's where, at least for me in doing my research, that's where I seem to find the most information about beta-glucans as being called biologic response modifiers because of their ability to profoundly activate the immune system. Now, I just want to mention that when I talk about activating the immune system and upregulating, I'm not really talking about activating in the sense that if your patient's got autoimmune diseases, I wouldn't be worried about giving them beta-glucans and up-ramping their immune system even more. I'm really talking about modulating the immune system. So that if the immune system is decreased, beta-glucans will upregulate, and if there's autoimmune disease, beta-glucans will help modulate and downregulate, just in the sense that it helps to kind of balance things out. So I'm not concerned about patients with autoimmune disease and beta-glucans. If you're taking supplements of beta-glucans, they are available in the form of supplements as well. You should probably take them on an empty stomach for maximal absorption. But just want to go back and just mention again that when you read the research on beta-glucans, the area that you'll see the most research on is as they relate to the immune system. Here's another type of very gelatinous, very viscous type of soluble fiber known as glucomannan. This paper was published in the Journal of the American Journal of Clinical Nutrition in 2008, where the authors write, glucomannan appears to beneficially affect total cholesterol, LDL cholesterol, that's our bad cholesterol, or triglycerides, body weight, and fasting blood glucose, but not HDL cholesterol or blood pressure. So I know that we use glucomannan in our office at the Palm Harbor Center for Health and Healing. And again, What glucomannan will if you use it in the form of a supplement, it's going to be a powder-like substance that you mix with water, and it becomes, again, very gelatinous and very thick. And you can prescribe it for your patient about an hour before a meal, and not only will it give them that really great feeling of satiety so that they have better control over their next meal, but it also helps, where the research is telling us that it also helps to lower their blood sugars. So you'll see a lot of data as it relates to blood sugars and glucomannan. It goes under the names, a few different brand names as well. Glucomannan would be the generic. Insoluble fibers are a type of fiber that can be seen with the naked eye, such as the seeds on strawberries and the strands on celery. Insoluble fibers will change very little from the point of consumption to the point of elimination, and should not really be the majority of the fiber in your diet. If it is, you'll probably have a lot of GI upset as well. Insoluble fibers help to add texture and bulk to fecal matter to help really scrub the villi, right? You have to think of insoluble fibers as being the scouring pads for your intestines. Really help clean them out. So it's going to be really especially important for your patients who do tend to like to consume a high animal protein diet. Just a quick word about lectins. Lectins are a non-gluten sugar protein or glycoprotein found primarily in wheat. They're found in wheat, they're found in a few different kinds of grains, some legumes, some of your nightshade plants such as tomatoes, eggplant, potato. Lectins have gotten a really bad rap because they've been shown to damage microvilli, to cause leaky gut, immune dysfunction, contribute to food sensitivity. So there's some information out there about lectins and how some of our patients may need to avoid lectins in their diet. Soaking, fermenting, cooking grains may inactivate some of those lectins by neutralizing the trypsin inhibitor component. Moving on to alternative sweeteners, not to be confused with artificial chemical sweeteners. Alternative sweeteners, I think of alternative sweeteners as sort of a cousin to sugars. So you may know alternative sweeteners that go by names like sorbitol, mannitol, xylitol. You've seen them in your dietetic candies and diabetic cookies, gum. I'm sure you've seen this in various products. These types of sugars do convert into sugar in the bloodstream, but the insulin response may not be quite as high as regular sugar. So just as an example, if you've got a person who's eating 3 cookies that have this sorbitol in them versus 3 regular cookies with regular sugar, both of them are going to have a blood sugar response. But the one who has the type of cookie that's got the sorbitol may not have quite as high of a response. But it's important that our patients understand and that we understand that these are not completely calorie-free foods. These are not completely sugar-free. Now, what's confusing is that when you go and look at the label of a food that's got these kinds of sugar alcohols in them, it will say sugar-free, but that's because that means it's regular sugar-free. It's sucrose-free. But the product will still have the sorbitol or the sugar alcohol, and you want to make sure that your patient understands that so that they're understanding that how that can affect their blood sugar. Now, artificial chemical sweeteners are really a whole nother story. Some of these go by names like NutraSweet or Equal, generically known as aspartame. That would be the little blue packet. Sweet and Low, generically known as saccharin. That would be the little pink packet. Splenda, also known as sucralose. That would be the little yellow packet. Now, technically, these substances do not convert into sugar. Now, there's some controversy as to whether they actually still cause an insulin response, if they still stimulate appetite. You know, I don't know that I have the answer to that. But technically, they don't convert into sugar. Now, I personally am not a big, huge fan of any of those chemical substances. And when my patients are coming to me and I'm recommending a whole foods diet, these are not typically substances that I'm going to recommend that they eat just because they're calorie-free. Right? So we don't want to teach at least I don't want to teach my patients that just because something is calorie-free. For example, diet Jell-O, which is really nothing more than water and some red dye and some artificial chemical sweetener. This is not something that I'm going to be recommending that my patients eat just because it's calorie-free. And I think this is important because there are some health professionals out there that would say that these kinds of foods are perfectly fine. Your diet drinks and your diet products. A safer alternative that you might want to consider is something called stevia. I'm sure by now many people have heard of stevia. It comes in a lot of different brand names, but stevia is going to be a safer alternative to recommend. Now when you ask the question, all right, so how many carbs should I be telling my patients to eat? That totally depends on who's asking the question. That totally depends on who we're talking about. If you're dealing with an endurance athlete, and what I mean by an endurance athlete is someone who's really training 5 or 6 days a week, at least a couple of hours a day, you know, their diet can go as high as 55 to 60 grams, 60% of their total calories coming from carbohydrate. If your patient's a recreational exerciser, and I'm thinking of a recreational exerciser as someone who's going to their fitness facility 3 or 4 times a week for maybe a 1-hour group exercise class, you know, this person's carbohydrate intake will probably need to be a little bit lower, maybe closer to 45 or 50% of their total calories. Now when you've got people coming in for weight loss, you're going to have to lower it. You're going to have to lower those carbs down to probably closer to 40 or 45%. That's assuming that there's no other medical issue going on, such as an autoimmune disease or inflammatory bowel disease or anything like that. And then if your patient's got diabetes, type 2 diabetes, you're going to have to lower it even more. It's going to be very difficult for your patient to control their blood sugars when they're eating a lot of carbs, bottom line. Even with the various supplements and with the high quality diet, too many carbs are just going to be very difficult to control. So you're going to have to lower that carbohydrate intake to probably about 40% of their total calories, maybe even a hair lower. It's going to vary from person to person. And of course, if your patient's on a ketogenic diet, which is essentially a high-fat, very low-carb diet, sometimes these kind of diets are used for patients who to control seizures. Your carbohydrate is going to be very low, like as little as 5% of total calories. Okay, we're going to move on to lipids. It's really all the time we have for carbs. And we just have to move right on. So, I hope you got that. Lipids. Lipids are an umbrella term. Lipids are an umbrella term that include your triglycerides, your phospholipids, and your sterols. We'll probably spend the most time talking about triglycerides because triglycerides really make up the majority of the diet. So triglycerides, just think of triglycerides as 3 fatty acid molecules that are esterified to a glycerol backbone. And that's a picture there for you. Those are your 3 fatty acids, and that's your glycerol backbone. So bottom line is triglycerides can either be saturated or not. Right? They're either saturated or they're unsaturated. Now if they're unsaturated, they can then be further divided into being either monounsaturated or polyunsaturated. And of course we all here have heard of the term trans fats, which are mostly found in the synthetic form, but some actually do occur in the distal stomachs of ruminants. So just quickly, some of the basic functions of fatty acids. I think at the very top of that list is to provide calories or energy. 9 calories per gram. In other words, for every unit or gram of fat, we can shove 9 calories of energy into that thing as compared to something like carbohydrates or proteins, which you can only push about 4 calories into that gram. Why? Because carbohydrates and proteins are hydrophilic, as opposed to fats, which are hydrophobic. So you're going to be able to pack in more energy, unit for unit, in a fat molecule. And so they're going to have higher calories per gram. Obviously, they function as an efficient storage of energy. We all know that part very well. Insulation, protection. The transport of your fat-soluble vitamins are going to be in your fats. Obviously, the fats are there to help us feel full, and that's what fats are what make food taste so good. So they give us that flavor and that mouthfeel. Dr. John Bagnulo, our wonderful former food as medicine speaker, always says, "You are the type of fat you eat." And I love that, and that's actually I'm going to explain that in a little bit as to why that is so true. But first, just very quickly, don't let these chemical forms intimidate you. The real point here is that top line is what you're looking at is a saturated fatty acid, and the point is simply that we call it a saturated fatty acid because it's saturated with hydrogen bonds all around that carbon chain. Really, that's just the main point that you want to look at. You want to note for that. And then the second fatty acid there is considered a monounsaturated fat simply because there's one double bond. So as soon as you have one double bond, that's considered an unsaturated fat, and then we can further characterize it because there is only one double bond, it's called a monounsaturated fat. And then if it's got if the fatty acid has 2 or more double bonds, then we simply call it a polyunsaturated fat. And then that third line is illustrating an omega-3 simply because the first double bond is occurring at the third double bond at the third carbon of the omega end, that methyl end all the way on the left there. And then your polyunsaturated fat at the bottom is an omega-6, simply because the first double bond is occurring at the 6th carbon from the methyl end or the omega end. Which is really not incredibly important information, but the point is that this is what your chemical forms of your common lipids look like. So the point, again, is that the double bonds are the primary site for oxidation to take place. If there are no double bonds in that molecule, there's going to be very little opportunity for oxygen to react with the molecule, which is why they have such long shelf lives, which is why saturated fat has such a long shelf life, and why, generally speaking, it's going to be actually better to cook in high temperatures with something like a saturated fat, because it is saturated with, and there are no double bonds, and so there's very little opportunity for oxidation to take place. A couple words about saturated fats. Again, no double bonds, a stiff and rigid structural influence on your cell membrane, which can be packed tightly together very tightly. Your primary sources are going to be associated with your mammal tissue, so your meat and your milk, and also tropical nuts and oils, which we'll talk a little bit more about. So if your diet is high in saturated fats, and this is what Dr. Bagnula was trying to say, this is going to be demonstrated in your cell membranes in as little as 1 month. So here are just a few different kinds of saturated fatty acids. Lauric acid, which is a 12-carbon, 0 double bond fatty acid. Myristic, which is a 14-carbon, 0 double bond fatty acid. Palmitic. But stearic acid is really unique. Stearic acid is kind of a neat fatty acid, an 18-carbon, 0 bond saturated fatty acid, because it's never been shown to elevate lipid levels. It's not considered atherogenic. And stearic acid is what's found in our tropical oils, particularly the unrefined forms. So your unrefined palm oil has that long shelf life. Why? Because it's saturated and it contains stearic acid. It's a great substitute for trans fats, obviously, so it's going to be excellent for cooking. But we still don't want it to be the primary fat in our diet. Your unrefined coconut oil is going to be slightly less saturated, but so that its shelf life is not quite as high as unrefined palm oil. But again, stearic acid is found in coconut oil. So these are just some pictures for you to take a look at here, your unrefined palm oil and coconut oil. When it comes to monounsaturated fatty acids, now because of that 1 double bond, these are going to be somewhat resistant to oxidation. And because of that, it's going to help to promote cell membrane fluidity better. There won't be a significant influence on icosanoid production. You'll form free radicals at temperatures greater than 325 degrees. Why? Because there is a double bond. So there will be, so the smoke point will only be so high. But its flexibility, because of that 1 double bond, makes it a happy medium to comprise a large percentage of our cell membranes. And this is really the clinical pearl here, or the key point that I think you want to, the takeaway here, is that the chemical characteristics that we see on the outside or outwardly are demonstrated physically when they are made a large part of our cell membrane. Your best sources of monounsaturated fatty acids will include foods like avocado, which actually does have a very high smoke point. And Rebecca Katz, our chef, will talk to you a little bit more about that. Extra virgin olive oil, almonds, peanut oil. Now canola, so you know there's no such thing as the canola plant, right? Okay. Canola oil is an invented name. So can you guess who invented it? The Canadians, right, okay. It's made from genetically modified rapeseed oil, and it's got a very low smoke point. Now there are some refined versions of it that have a higher smoke point, but Rebecca will probably talk more about that. Your polyunsaturated fats, so we've got 2 essential fatty acids. Our alpha-linolenic, which is the omega-3, so it's an 18-carbon, 2 double bonds, omega-3 type of fatty acid, which is extremely susceptible to oxidation. Now, alpha-linolenic acid eventually goes through a few steps to become your fully formed, or what I like to call your fully formed omega-3s, such as EPA and DHA. Right? You've all heard of EPA and DHA. Your sources of alpha-linolenic are going to include nuts, marine algae, purslane, and seeds like flax. But alpha-linolenic acid by itself is not really what our neurologic tissues need. there is a difference between ALA or alpha-linolenic acid and your fully formed omega-3s like EPA and DHA, and that conversion at best is only about 20%. So all of that extra alpha-linolenic acid can produce free radicals, and a large and excessive pool of these can definitely be a problem. So we want to be sure that we understand the difference. Now whole flax, the whole flax seed will be a great source of omega-3s, but as humans we lack the digestive capacity to really extract the omega-3. I mean, unless you're a bird, you're really not going to be able to get the alpha-linolenic acid out of that flax. So you're going to either have to grind it, buy it ground up, and then of course store it because then in the freezer because you don't want it to go rancid, or you'll have to grind it up yourself, and you can buy an inexpensive coffee grinder and it grinds immediately, and you can grind it right before you want to use it. It's very quick and very easy. Now linoleic acid, which is your 18 carbon, 2 double bonds, omega-6. So alpha-linolenic, omega-3, linoleic acid is your omega-6. We've got 2 essential fatty acids, and these are the 2. This is also highly susceptible to oxidation, particularly lipid peroxidation. You can actually measure lipid peroxidation in blood studies looking at something called T-bars and F2-isoprostanes, which we do in our clinic all the time. So if alpha-linolenic acid is the precursor to EPA and DHA, then linoleic acid is the precursor to something called arachidonic acid, which can fuel the production of your series 2 eicosanoids. But omega-6 is...
Sheila,
yes.
Can you just explain eicosanoid a little bit?
Sure. Absolutely. So eicosanoids are the substances like your prostaglandins, your thromboxanes, your leukotrienes. These are relatively pro-inflammatory and hormone-like substances. So I don't know if that helps to expand a little bit. Thank you. We frequently talk about how the standard American diet is just too high in omega-6s, and obviously that's true. The ratio is probably, right now, the standard American diet ratio of omega-6 to omega-3 is probably something like 30-to-1, which is definitely too much. But that doesn't mean that omega-6s are the enemy. They are not the enemy. Omega-6s are still critical for immune function and important for hormone health, but really it comes down to balance. It always comes down to balance, doesn't it? So 3-to-1, a 3-to-1 or a 2-to-1 ratio is a good ratio of your omega-6 to omega-3s. You can imagine that the reason why it's so easy for that ratio to become so wide is because look at the sources of your linoleic acid. Your vegetable oils like corn oil, safflower oil, sunflower oil, and think about what most people cook with. Right? That's what they're primarily cooking with, these kinds of vegetable oils. So they're getting a lot of these omega-6s. So while omega-6 is absolutely an important substance, we need to lower the amount. So when your patients are coming in and asking you if it's okay if they take a supplement that's got omega-3 and omega-6, generally speaking, I usually try to dissuade them from taking extra omega-6 and just take omega-3s unless there's a real reason why they need to take the extra omega-6. You might want to teach your patients to consider substituting some of these vegetable oils with grapeseed oil instead. So just a simplified illustration of your omega-6s and omega-3s. So your omega-6, as we said, linoleic acid goes on to produce gamma-linoleic acid and then eventually arachidonic acid, which too much of arachidonic acid is obviously pro-inflammatory, right? Too much of it. But your omega-3s go on to eventually become, or alpha-linolenic acid eventually becomes your fully formed EPA and DHA. Now what I want to point out on this slide is that enzyme, that delta-6 desaturase enzyme, which may seem like a minor point, but actually it's an important one. So delta-6 desaturase is the enzyme that helps that conversion for both omega-6 and omega-3 fats to convert into their fully formed versions. Just want to point out that delta-6 desaturase is a zinc and magnesium dependent enzyme. So if your patient's not getting enough magnesium or zinc for whatever reason, whether it's because of a poor diet or another reason, that may inhibit that process. The other thing that we want to know is that trans fats also are inhibitors of the delta-6 desaturase enzyme. 2 or more alcoholic drinks can potentially inhibit the delta-6 desaturase enzyme. Certain medications like SSRIs can potentially inhibit the delta-6 desaturase enzyme. So we want to be aware of, our patient's whole story and really get the details so that we're better understanding what's going on with their system, with their situation. Food sources of your EPA and DHA will include things like cold water, fatty fish. That cold environment is a stimulus for these organisms to have a concentrated amount of omega-3s in their tissues. Wild game, egg yolks of chickens that were fed flax as opposed to corn, so flax or even walnuts. Canned sardines have been referred to as antidepressants in a can because they offer something like 4,000 milligrams of EPA and DHA per can. I'm not a huge fan of canned sardines, but they are an excellent source. And another thing I wanted to mention, actually we now understand that EPA and DHA also help to upregulate PPAR receptors. PPAR receptors or they act as PPAR agonists. Just think that of PPAR receptors as being substances that help to sensitize insulin. Your drugs like metformin or glucophage, which is a brand name, are PPAR agonists. They help to sensitize insulin. And there's some research that shows that EPA and DHA can have a similar effect. So I think that's an important point. And again, just as a reminder, we said that trans fats not only inhibit the delta-6 desaturase enzyme, but they also downregulate PPAR receptors. So trans fats can contribute to what then? Insulin resistance. Here are some of your plant food sources of omega-3 and omega-6 for your reference when you have a moment to take a look at that. And on the next slide, some animal food sources of omega-3 and omega-6. So these trans fats, or maybe we should call them toxic fats, are found in our partially hydrogenated oils. Did you know that New York and California has banned trans fats in their restaurants? You probably know that by now. So the thing about the reason why these trans fats are so disruptive to cell membranes is because of their unnatural shape that's just reaping havoc on your cell permeability. It disrupts cell communication, which leads to a decreased cell fluidity and permeability, and decreased ability of the molecules to move across the cell membranes because of that unnatural shape. Again, we talked about it blocking the formation of the long-chain omega-3s via that delta-6 desaturase inhibition, getting in the way of PPAR activity, but it does have long shelf life. It does have complete resistance to oxidation, and you will get uniform texture in oil-containing foods. I think that it was interesting when I learned that the fat biopsies from women with breast cancer showed higher levels of trans fats in their tissue as opposed to women who didn't have breast cancer. It's an interesting thing that I learned. So here's a picture. You all have probably seen these in some of your basic biology or chemistry classes. This is the cis form or the regular form of the fatty acid, and if the hydrogens are on the opposite side of the carbon chain, that's called your trans form, or which contributes to which is what makes that trans fat. And this is just another reference for you to look at some of your sources of trans fats. This is also an interesting slide that shows you some of the composition of the different fats. One thing I just want to point out about this is you can see that no one fat is completely saturated or completely unsaturated or only monounsaturated. For example, olive oil. Olive oil is primarily monounsaturated, but a little bit saturated and a little bit polyunsaturated. So all of these oils are sort of combinations, and we call them poly or mono or saturated based on what they are primarily. Okay, we're moving on to phospholipids. Phospholipids such as phosphatidylcholine and inositol are your most abundant membrane phospholipids. Think of that lipid bilayer around the cell. They play huge roles in cell membrane structure and signaling. They're critical for methylation. They're important for neurologic development and lung health, and they're found in highest concentrations in foods like egg yolk, shellfish, nut butters, seeds, and beans. Here's a picture. Now remember I showed you the triglyceride with the 3 fatty acids esterified to the background, the glycerol backbone. So phospholipids are similar with one major difference though. So a phospholipid has 2 fatty acids, but instead of the 3rd fatty acid, or in place of that 3rd fatty acid, is a phosphate molecule with a choline molecule, which is sort of like a B-type vitamin. at the top, and the choline molecule is what gives it its hydrophilic quality, so that the hydrophobic tails will be on the inside of the cell, and the hydrophilic head will be on the outside of that lipid bilayer, and that's what a phospholipid sort of looks like. And then finally, moving on to cholesterol. I mean, obviously there's a lot that we can say about cholesterol, right? Entire symposiums revolve around just cholesterol. But for today, just want to let you know that it's not so much cholesterol, but really oxidized cholesterol, or maybe even specifically oxidized LDL that damages the artery wall. And vitamin E, or the natural form of that, vitamin E helps to protect the integrity of that membrane by inhibiting that lipid peroxidation. And that dietary cholesterol, and I really want to put this one to rest, dietary cholesterol really is not what makes your blood cholesterol go up. Right? So your patients who come in and say, well, I've been told that I need to eat a low cholesterol diet because I have high cholesterol. Well, that's not really a bad thing to do, but it's really not the best way to lower cholesterol. It's not really, and again, the reason is because I think we now understand that dietary cholesterol is not really what's pushing serum cholesterol up. Indeed, your endogenous cholesterol production is governed by a variety of things, including your insulin levels, which will be influenced by the carbohydrate that you eat, concentrations of amino acids in the forms of protein, and then of course specific fatty acids as well. Okay, we are going to move to protein. Amino acids. So I know you've heard of the term amino acids. Amino acids are the building blocks of protein. We've heard that, but what exactly does that mean? I think the simplest way I can describe it is if you had a string of beads. Each one of those little beads represents an amino acid that, when strung together in a variety of different sequences, gives you a protein with a unique function. This is an example of what a basic amino acid looks like. It's got a carbon core, it's got an amino group, it's got an acid group, and it's got a side group, that R group. It's that R group that, depending on what's in there, will determine the function of that amino acid. So for example, if you stuck something as simple as a hydrogen atom in there, that would be glycine. Right? But if you stuck a different molecule in there, it would make a different amino acid with a different function. Just a couple of key points, and there really are so many things that we could talk about, but we're just going to highlight a few things. Particularly relevant for vegans and vegetarians, complementary essential amino acids don't have to be consumed at the same exact meal, the same exact time, but optimally within 24 hours. Okay? The other thing I wanted to mention is that large influxes of amino acids after a protein-rich meal can alter blood pH. Now, let me just take a moment to clarify here what we're talking about, because this is really kind of tricky. Your blood pH is very tightly regulated, right? It always stays at a tight 7.38, maybe 7.4. But in order for your body to maintain that really tight 7.38 or 7.4, your body has to go through a variety of steps in order to do that, in order to keep your blood pH alkaline like that. You know that the pH scale goes from 0 to 14. 7 is neutral, so 7.38 is what? It's slightly alkaline. And if it were to be anything else, you would end up in the what? In the ER, right? Now, tissue pH can vary. Why do we know that? Because if you were to do a urine analysis, you would see that your patient's urine pH can be as low as 5. So we know that urinary pH can vary, but blood pH is very tight. So when the body is working hard to try to maintain that tight 7.38, and you're eating a lot of foods that are very high in protein, really creating this high, this acid-loaded state, what your body's going to do is it's going to stimulate the osteoclasts, which are cells that break bone tissue down to remodel the surface of the bone, and put calcium out into the blood to help to buffer out all of that protein, all of those acids, right? So when you're eating a diet that's high in fruits and vegetables to compensate for that high protein diet, then your body does the opposite. Then you have the osteoblast activity. Osteoblasts are cells that help to build bone. And when that happens in the presence of these alkalinizing minerals, then you can improve bone density. So let me say that again. If your diet is very high in protein and you're not getting enough of your alkalinizing minerals from your fruits and your vegetables, then what happens is it's going to affect your body's pH. And what your body needs to do to maintain that tight blood chemistry is to find an alkalinizing buffer. We don't want to use our bones as an antacid, right? We don't want to constantly pull from the bone to pull that calcium to buffer out all of those amino acids. Does that make sense? The reason I threw this slide in there is because people ask about this all the time. And I just have one slide on this subject, and that is that Dr. Colin Campbell wrote this book called The China Study. And I think people who don't really actually read the book think that the book is basically about high protein diets and cancer, but actually it's more specifically about his findings, which were that high casein, which is a type of protein found in cow milk particularly, diets were associated with certain cancers. Not just really high protein diets, but high casein diet. That's all we're going to say there. So ultimately, balance is the key. Animal protein can increase levels of insulin-like growth factor and can decrease glucagon production. So again, IGF-1, an important hormone, but it's the overproduction that can increase your cancer risk. So same theme, we want to avoid a diet that's too high in animal protein, or what we call our acid-loading grains, this wheat and corn, which contributes to the renal acid load, or the potential renal acid load at each meal, because over time, your body just can't compensate for this. The reason I show you this slide, and you may have seen this slide, and you're probably going to see this slide again, this is a very common slide, that gets put up quite a bit, is just to show you very quickly that in the process of liver or hepatic detoxification or biotransformation, amino acids are particularly used in your phase 2 or your conjugation pathways, where you're taking that very volatile intermediate and you're trying to basically unload that loaded gun. And amino acids are needed for that process. We'll come back to that slide. We'll see that slide again. I just have a minute or two to wrap it up. So I'm just going to say one or two key things about some of these different amino acids. Branched chain amino acids, when you think about branched chain amino acids, just basically think anabolic in nature, and essentially what you'll find is that the research shows that it's excellent for muscle recovery. So think athletes, branched chain amino acids for your patients who are looking for muscle recovery. Glutamine. When you think glutamine, I want you to think about the single most important amino acids that feeds the lining of the cell. Your villi and the cells in your intestines are some of the most rapidly dividing cells in your entire body, and glutamine is the amino acid that feeds the cells of the gut. The splanchnic area are basically referring to your gut organs. Glutamine is extremely helpful in improving gut permeability. So when you have a patient that's got something like intestinal permeability or leaky gut, glutamine can be very helpful. You have to be careful though. Glutamine can be neuroexcitatory, so you have to be careful if you have a patient on some type of anti-seizure medication. You're going to have to be careful about that. Another area that you can use glutamine is in your athletes in terms of muscle recovery, athletes that are overtraining, athletes that are complaining that they're getting sick a lot. Glutamine will upregulate the immune system. You can start with as little as 100 milligrams, and you'll see a lot of medical food products that various companies put out with as little as 100, all the way to products that contain as much as 10,000 milligrams or 10 grams. So that glutamine is also an important precursor for another amino acid called arginine. When I think about L-arginine, what I think of is the precursor to an extremely important signaling molecule called nitric oxide, which is very important for vascular health particularly. Main thing that I want to point out is that folic acid, which we're going to talk about, which is a B vitamin, is needed for something called BH4 or tetrahydrobiopterin, and BH4 is needed for the enzyme eNOS that helps to facilitate arginine becoming nitric oxide. So let me say that one more time. Okay? Folic acid is needed for BH4. BH4 is needed for that enzyme eNOS, or endothelial nitric oxide synthase, and eNOS is the enzyme that pushes that reaction through arginine, which becomes nitric oxide. So what I'm saying is that if you're concerned about your patient's vascular health and you're giving them a little bit of arginine, give them a little extra folic acid as well to help push that reaction through. These are just a couple of papers for your reference. I'm going to have to slide over these. These are just articles that talk about some of the areas that nitric oxide is involved in, which is everything that we just basically said, including various reproductive processes that are regulated by nitric oxide. And glycine. Glycine is that amino acid that I referred to earlier. Very, very important part of phase 2 or step 2, whatever you want to call it, liver detoxification or that conjugation pathway. In this particular example, you see that glycine is involved in helping 2-methylbenzoate convert into 2-methylhippurate. You'll see glycine used in a lot of medical foods and functional foods, and again, when you think of glycine, think liver detox. And there it is, right there in our liver slide again. And then finally, taurine. Taurine is another amino acid that is a sulfur-containing amino acid that works a lot with magnesium. Taurine and magnesium work together. They run together. Taurine has all kinds of biologic effects. Insulin regulation, you'll see a lot on beta cell preservation, cardiovascular, as an antihypertensive, antioxidant, membrane stabilization. You'll just see research in all areas. So taurine's a big one, involved in all of these areas, and also again, when you think taurine, we're going to talk about magnesium after the break. Think taurine and magnesium working together. Protein needs. Don't just simply have your body weight to determine protein needs. Try to take in consideration the patient's individual age, their gender, their life cycle, their activity level. Now the RDA right now is only 0.8 grams per kilogram of body weight. I think that needs to vary based on your patient's baseline physiologic status. Are they a burn patient? Are they sarcopenic? Are they an athlete? You can do an assessment using a very basic metabolic panel, which will be discussed in the assessment discussion. Like you can look at total protein, you can look at albumin. And finally, I think this is my last slide. Finally, just a couple, I think this is a great reference slide in learning about just a few of your plant sources and your animal sources. Just want to point out these grains. Take a look at quinoa. Per 1 cup, quinoa actually has 8 grams of protein. That's pretty amazing. 8 grams of protein for 1 cup as opposed to barley, which has 3.5 grams of protein per 1 cup. You know, most grains are actually missing the amino acid lysine, but quinoa actually has quite a bit of lysine. It's not quite as a complete protein as, let's say, an egg is, but it's pretty close. Quinoa is pretty close. Seeds are an excellent source. I'm probably not going to go through every single one of these, but you can see that hemp, only a 1/4 cup of hemp will give you 20 grams of protein. Extremely nutritious food is hemp. Your animal sources, generally speaking, 1 ounce of cooked fish, poultry, red meat, wild game, approximately 7 grams per 1 ounce cooked. 1 egg is going to give you about 6 to 7 grams, but not if you split that egg apart. If you get rid of the yolk, there goes 3 grams. Yogurt, cottage cheese, these are some of the amounts of protein that you can find in these foods. So, we are done with macronutrients. So what I'd like to ask you to do is to stand up. Now, try to give yourself a little bit of space. So take advantage of the space in the aisles here, because you don't want to smack anybody in the head. Take a moment to take a deep breath in through the nose with me. You ready? Deep breath in. Exhale out. One more time. Deep breath in. Exhale out. Now turn to your left and put your hands on the shoulders of the person in front of you. Okay? Now give them a nice little rub. Nice little massage. Oh. A little bit more, a little bit more. Make sure you get it good. Really dig that thumb in. Really dig it in there. All right, ready? Now switch, turn around to the other side. Really dig it in there. Oh. Thank you, darling, you're so sweet. All right, fantastic. Thank you so much, honey. Thank you. Kathy, how long of a break are we taking before we start out with micro? I think
we're going to take a 5-minute break. 5 minutes. Get up, move around, play around. Whoops.
Hi.
Thyron. I actually
Excuse
emailed
my-
you when
my
you were
very
like,
cold hands.
I'm on DIFM.
Oh.
Yeah. So thank you. It's just so nice to actually see you in person. 'Cause I see this like little picture of you.
Yeah.
I have a
sorry that was
question.
So fast. You know,
but
I'm still on right now. Let me see. Hang on.
I'm
Gabe,
gonna
can you shut me down for a moment? Gabe, can you turn me? Can you turn me off? He doesn't hear me. Yes, go ahead.
Do you want me to save my question for the end and give you some time? Thank you.
Gabe. Yeah, it's going to turn me down for a second. Hey, Gabe, can you turn me down a little bit? Turn me down. Turn me down.